The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, a group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont from HVERI, the Hawaiian Volcano Education and Resilience Institute. Today is Thursday, March 21st, 2024. Kilauea is still not erupting, very quiet on the surface, but underground slowly filling. And we'll cover that much as we did last week. It'll be similar update to last week, Dane, where we cover the signals and then we'll recap the Volcano Awareness Month presentation. And this week will be our geochemistry talk from Dr. Kendra Lin. So before we get to all that, how are you, man?
I'm doing good, doing good. Just, keeping up with everything. Not a lot of volcano stuff happening right now. A lot of other stuff happening, but keeping us busy, at least. But yeah, well, it's nice at the volcano to give us this opportunity to go back and review the Volcano Awareness Month talks that people might have missed during January.
Yeah, for sure. So shall we get into it?
Yeah, if anybody has any questions or comments, go ahead and drop them in the chat and we will try and get to them at the break. Instead, at the end, we'll do them more in the middle and then we'll have another video presentation like last week.
All right, thank you, Dane. So let's rearrange our screens here and let's get ready for our summary. So in our Hawaiian volcano summary this week, we have earthquakes down slightly this week from the very slight increase last week from the previous week and the rest of the past month, but still very low earthquake levels overall on Kilauea in many of the same areas as we've seen recently, largely moving from the South Caldera area down at Southwest Rift Connector to the Southwest Rift Zone. This is the last week of earthquakes map from the USGS, and very similar to last week there. Looking at the tilt meter at the Sand Hill Station just southwest of the caldera, this green line is showing this whole last month of inflation that's reaching close to 20 microradians now. That's just a fairly noticeable, significant increase of the ground tilt that's been fairly steady for the last month, all of which follows that big pulse of magma intruding to the Southwest Rift at January 31st. So since then, it's been coming back up, and that rate has not slowed down despite the slowdown in earthquakes we've seen over the last month here. At the same time, this blue line, which is pointing more towards the Halema'uma'u crater within the caldera, has been deflating, suggesting that the center of that magma buildup is still in that southern part of the caldera and that southwest rift where it intruded. So likely those pathways are still open, and as magma comes into the volcano, it's slowly filling those areas, but not able to really pressurize enough to cause earthquakes, as that magma is able to continue flowing through the passageways underground to where there's less pressure. So very similar. If we look at our INSAR image, this is a satellite radar measurement for the 2 weeks until March 16th. You see that much of the southwest rift connector area, some of this Kauai fault zone area, and this maybe southern half of the caldera, southern and eastern half, appear to be the center of magma buildup underground, where the ground above it has been bulging enough that the satellite can then measure it through radar. So this is a little different. It's expanding a little bit more to the north here, but within the last few days, if we look at the Summit Caldera GPS, north and south, we'll see there's a slight turnaround and slowdown here in the distance north and south across the caldera, which suggests in the last few days that perhaps the center of bulging has shifted south once again. So very dynamic area, very dynamic situation now with the magma filling underground and moving from place to place, but overall not building enough pressure to cause any earthquakes or threat of an eruption quite yet. Still recovering from the intrusion. That's Kilauea. Maunaloa is equally quiet right now. These are the last 5 years of earthquakes per month. And we are very, very low here at the bottom, at the lowest point ever since the eruption in late 2022. So that's our Hawaiian volcano summary for this week. And we can turn to some observations on Kilauea. And I thought we would play just a live camera from about an hour or so ago. We had this little rain cloud passing across the camera, and we can see the rainbow marching across, fumes littering the hardened crater floor. There's still some magma mush underneath all this, magma or lava, right? But the areas where you see all this discoloration is where the gases are coming out and leaving mineral deposits from the magma. A patch over here, a big one in the middle, and along the crater walls as well. It's still pretty evident all through there. So quiet underground, still beautiful on the surface, but not a whole lot of activity to talk about today. Gas-wise, gas is still the biggest hazard to people in and around a volcano, and the levels are actually quite low. Everything is in the green in the national park, but even still, people who are sensitive should take precautions if they live in nearby areas or are visiting these areas. There's a pretty quick hazard summary there, and we'll move on to our monitoring this week next. So we'll start with the USGS update, which was issued weekly now this past Tuesday. And there's really not a whole lot of change in here. There's no eruption. Rates of deformation are low. There's low levels of earthquakes, and they're still in the same areas. that is basically it. SO2 rates are still low at 85 tons per day. They note that over the last 2 weeks, there were there was a slight increase of earthquakes, but still well below those detected during the intrusion. And both rift zones closely monitored. So that is the USGS update there. Next, we'll turn to the MOUNTS system, right? MOUNTS is automatically capturing satellite data for volcanoes all over the world. This is the Kilauea page from which we can take this INSAR image, which is released every 2 weeks or so. So as we mentioned at the top, this was from March 16th, the 12-day interval, and it's about how often they come out. And for comparison, I'll flash back to the previous 12-day period to that. So here it is. This was March 4th, 12 days prior to that. You see there's a lot less happening here in the southern half of the caldera and more intense in this Kilauea zone right through here. Some signal, but not as strong in the southwest rift connector either, right? So I'll flash it back and forth once again. So this is now, well, not really now. This is 5 days ago on the 16th. And the previous 12 days, that was actually when it was centered more in the pit itself. So you see it started in the center, moved to the south, and now is migrated to fill both of those areas. And just one more increment backwards to that intrusion pulse. So this is when magma drained from these areas and flushed down the southwest rift, leaving this big signal. So I'll advance back through time. So from the intrusion, refilling first under the center, and then next moving to the south, the Kilauea zone. Next, refilling back to the south caldera and more clearly filling the southwest rift connector. As I mentioned, this was for 5 days ago. So within the last 5 days, we can look at the GPS signal where it does look like there might be some contraction between around here and here, right? Which would suggest that maybe less of this is going on in between those two zones, just with less sidewards push in that case. So we'll see how that turns out. But that's the snapshot of what's been happening since the intrusion. To put that in some perspective, let me switch us over here to Google Earth. And I've superimposed that most recent INSAR image on our landscape here. So you can have some idea of how that looks. And for one, you can notice that this is a fairly small area that we're covering. We're talking about magma moving all the way down into this area all through here, which we'd love to have INSAR image of, but for this particular panel is not included. So we'll use what we have here. But looking closer in at the summit, this is the north side of the crater up here, which is not really showing a whole lot of movement. So Uekahuna, oh, what happened there? Okay, there is Uekahuna. Not really moving very convincingly either north or east or west. The north-south signal is pretty flat as well there. Let's see, I think I'm tapping things accidentally here. So not a whole lot of movement, although if we look at the upward signal, it is still slightly creeping up. Right, that's what's important at Uekahuna. Looking at the eastern side of the crater, Byron's Ledge Station over here, similar. You see both of those are in that green zone outside of that bullseye of inflation. So not a whole lot of north-south movement. It is getting pushed to the east, and it is still very slowly rising right there as well. So those are the eastward ones. When we get right into the heart of the action, it gets a little more tricky. Crater rim, when we look at that station, it's not really moving east or west. It's not really moving north or south, but it is very slowly rising. And if we look at the station just southwest of that, over here at Outlet, we might see a similar thing. It's actually moving, in this case, a little bit more to the east, not so much north and south, and slowly rising. And one more would be, so that one looks come down to Ahua. And similarly, not really moving east or west or north or south, but still very slightly rising. So these areas that are under this center of inflation all through here, so they're not really getting pushed sideways back and forth. They're all just getting lifted up by the magma swelling underneath them. And the ones that are further away, here and here, you can see them getting pushed one direction or other a little bit while still slowly bulging and as the volcano is bloated and pushes them upwards. So that's how that comes into play. Interesting, if you note down here, the Devil's Throat Station is actually outside of this zone of swelling. So it's not quite as far south as it was during that intrusionary pulse, which would lead you to believe that there is still plenty of space for the magma to flow to relieve pressure underground through there. Everything's been moving, and that creates space. So that's the important thing there. If we go to the stations that are further over, Mane, Maukakipukanene, that station is still moving east and south and slightly up. And the same is true at Hilinapali, all the way over here, moving east and south and up. And just like before, Ilemakule all the way to coast, all the way down here, is moving east and south. Not up, it hasn't really been rising, but it's still showing that movement that's faster than it was showing prior to this intrusion. And so the slope of the line, the angle of it here is showing you how fast it's happening. Right? Likewise, moving to the south, faster than it was over its long-term history here. Right, that station all the way to coast doesn't really rise or fall as much. It's a little bit too far off the axis. But just goes to show that even if we don't have any INSAR in this area, these three stations are still showing push to the southeast, which leads you to believe the magma that we see bulging in the INSAR over here is likely still filling to some degree, some distance, enough to keep this piece of land mobile and moving as it has been for the last several months here. So that's the active part. The areas that are less active are all the way over here, Jonica, the Pu'o'o station, not really showing any change. I can maybe pop one of those up. Let's put it here. And then some little wiggles on the east-west from the direction of the Southwest Rift and Summit. But the up signal is still decreasing, and the southern signal is still moving to the south there. It's not a whole lot of change. If you come to Kamoamoa and Kananui-Ohamo areas, there it does appear that the up signal, just like we mentioned last week, is still flattening out to some degree there. So perhaps that's the sign of the pending change for this segment of the rift, up rift of Pu'o'o. And the other station that we've always been looking at to try to get some clue from is this Kalapana Trail station, also Makai Makapui, but Kalapana Trail. We're looking at the north-south component here. Remember, this is the last 2 years. Had been moving to the north for a long, long time with little relief from eruptions. And so we can see that since October 2023, right, when we saw the first pulse of intrusion into the Southwest Rift, since then, we've been fairly steadily moving to the south more quickly here within the last 3 months than the first 3 months. So the reason that matters is if these two stations here and here were moving north, that pinches a rift zone closed. It goes right through here. And if they move south, that's what allows it to open, right? And this pathway of magma that might be refilling this upper east rift connector might then be able to go as far to perhaps in here. Another one of those wait and see situations. So that's the GPS link to the INSAR. I thought I'd show it a little differently this week. But we'll continue with our monitoring signals as usual. Looking at the tilt. Over the last week at the summit, we've had a slight rise, about 1 microradian. That bridges over a small deflation-inflation event and a larger one as well. Nothing unusual there. We're not really seeing earthquakes peaking during inflationary pulses like we sometimes do, suggesting that pressure there at that summit area is slightly lower than it's been in the past. And that makes sense if the magma has room to go elsewhere and not just build up in one spot. It's building up in several spots now. So here's depth versus time for the last week. And you see little flurries of earthquakes still ongoing. but nothing as intense as we saw last week or a couple months ago. So there's a map as we showed. Deep Pahala earthquake still ongoing, South Flank earthquake still ongoing. And most of this is really earlier in the week than recently. So we'll come to the more current data here shortly. For the last month at the summit, this is a Uekahuna station. We saw a more convincing rise over the first half of the month. It seemed like maybe it slowed down a little bit there. But here recently on the right end of this graph, it does appear to be rising more quickly now. So perhaps a slight slowdown here, slight contraction, or it's not really a contraction, a slowdown of this extension rate. It's going faster and slower, and then maybe it's going to pick up here, and we'll see as we see the center of swelling shifts north and south. It can vary a little bit like this as well. More interesting was a signal we mentioned in our summary, the sandhill, which is interesting to note. There's a little nuance here. The blue line, which we've often corresponded to the same Hale Ma'u signal, is actually deflating here, while the green line is inflating. So the direction of this is northeast from Sandhill, and this one is southeast from Uekahuna. So maybe I'll go back to our Google Earth just to show you the directions of that, how that might actually be. So this is the Sandhill station here, and northeast from it, it's more this direction there. So you might be pointing more towards a pit of Hale Ma'u. It's close to this area over here as well, South Caldera. Southeast is more over here. So that green line is picking up the signal from this whole zone in here more than likely, whereas that blue line is picking it up from somewhere in here. So from this direction, we're seeing deflation, but from the direction of Uekahuna, which is just up here to the southeast, we're seeing a slight inflation, right? So it might be possible that these signals, depending on where the exact center of the swelling might be, if it's there, or if it's slightly more over here, it's still southeast of Uekahuna to perhaps detect some inflation, but it's not quite so northeast of Sandhill. So when it starts getting very localized like that, not everything is acting in unison, all swelling. That's also another indication that things are localized here or there and affecting the stations differently. And just a little nuance that we can get into today since we have a little time for that. But really, we want to finish off our monitoring signals. There is a more complete depth time plot of earthquakes for the last month. So you see there's still good low-level activity happening, but it's not like what it was during the intrusion. So the counts reflect very similar to what we just said there. And in greater context for the last year, here is that pulse at the end of January, and here we are after the fact. Right? We've actually come down. You see much of the time between October, when this southwest rift zone phase began, and now have had higher earthquakes than we're having right now. Right? So really, this was the main work done to relieve pressure, and we're still showing signs of it filling slowly, but it hasn't pressurized enough to see what we're seeing for many of the past few months here. And for the last 5 years, we are still overall in heightened activity, but all the previous months having many thousands of earthquakes per month, thus far in March, we're still under 1,000 all the way down here at the bottom right. So we'll see how far we catch up, but it doesn't look like we'll catch up quite as far as the previous months recently. GPS will be the last thing here, and as we mentioned before, I'll zoom it in to make it more evident. There is that extension as the north and south parts of the caldera move further apart. That distance is getting larger. The dots are higher up on the graph here, right? Coming up higher. And here recently, maybe a little flatter and perhaps even coming down a slight bit here. So this is maybe where the last 5 days might differ from the previous 12 shown in the INSAR. So little nuances about where the magma is filling exactly here or there, but overall, very similar story. And down in the rift zone at Pu'o'o, still showing contraction and the ground dropping. Even if we're seeing the rift zone show signs of adjustment and perhaps magma might get in there, it's not showing that it's getting in there at any significant rate yet. And so therefore, no hazard, nothing to worry about for people living down the rift zone. That's just business as usual for Kilauea. So that's the monitoring signals. We'll look at earthquakes next. And I'll show you, as usual, the earthquakes plotted colored by depth. So the blues are deep earthquakes, or reds are shallows. You see there have been some deeper earthquakes in the north part of the island, even some shallow ones over towards Waikoloa area. These are all settling, whether they're deeper or shallow, that whole stack of, I think of it as like a magazines, right? Like there are all kinds of different layers that are all in there. They can all adjust at any level. The bottom can shift, the top can shift. So all of that is normal, as long as they're not clustering in large numbers in a small area, right? And it's not following something like a main shock aftershock sequence for very big ones. So nothing concerning to see earthquake-wise elsewhere in the island. So we'll focus in here on the Kilauea area. The blues are the deep Pahala earthquakes. They're still ongoing. And for the last 2 days here on Kilauea, you can see just a handful of earthquakes. There is this one here that is showing up at 2.2 right there. 2.2 right under the caldera, a couple in the south caldera, southwest rift connector area, and a couple further on, but really fairly quiet. Let me come back up here and let's increase our time range here. Let's see, it's going to give me last 2 weeks. Let's do, and come down. So now you see a little bit more of where the earthquakes have been. The zones we talked about yesterday, and the one that was reviewed on a talk. The southern bend is deflection, a little bit more further over, another deflection over there. That's area of magma movement in recent months. And what I thought we could do is maybe here, let's go back to the full last month, actually. So come up here, let's go back the last 4 weeks. The map gets a little bit fuller, but it's not nearly that full compared to the earthquake swarm week. And let's try to make an earthquake plot here. So let's select an area for our plot. Let's start from down here and come up here. And let's hope this works. View my plot. Looks like it is. So what you normally get is your time depth. So time for the last 4 weeks and the depth of the earthquakes. Well, I'm showing all my deep ones as well, right? So deep earthquakes, shallow ones here too. We look in cross section, A on the left and B on the right. So there's a deep Pahala earthquakes all through there. That kind of shows you the pathway, we believe, towards Kilauea, up underneath the summit, probably more on this side over here, but somewhere in there, and moving down the southwest rift. And it's interesting to note that they do end up going deeper the further away from the summit they actually get. Right? So it's almost like it could be something like gravity, even though this is all underground. It is that fashion of that kind of pattern, anyways, right? I don't really know or believe how important gravity is when you have that much pressure from the surrounding rocks down at those depths, but it does get deeper here the further over you get, which is interesting. And as far as overall rates, this is the earthquake counts. And remember, when it gets steep, they're happening quickly. When it gets flatter, they're happening not as fast. You can see it's still having these pulses, right? And that was the more recent one there. So I like to filter out the deep earthquakes to have a better zoomed in plot. So let's try to do that here real quick as well. Let's just take off these 250 deep ones and these other 14 that are not as abundant. And let's try to look at our plot again. And especially the cross section here, A to B. So there is that slightly deeper zone further down the southwest rift. This is that area where most of the earthquakes were accumulating, where the ground cracks happened over the surface. These darker red colors are above sea level, above zero. And so that's the shallowest part, still showing some pressure there, right? So still showing some weakness in the ground, although not enough to quake at a high level. So it's still giving us an idea of where the magma is filling very slowly over the last 4 weeks here. And once again, you see that pattern of a pulse, a slowdown, a pulse, a slowdown, a pulse. So it's definitely not as intense and nonstop as it was during the main event in January. So that's the earthquake area, earthquake insight we can share today. The typical national earthquake map looks like this. We can look at the largest events over the last week. Were 3.3, 3.2, a couple of those, 3.1, all those were all Deep Pahala earthquakes. So the largest events have been all in Deep Pahala and fairly quiet on the surface otherwise, mostly adjustments elsewhere on island and quiet on the volcanoes. So Maunaloa, looking at the flank of Maunaloa, there are 3 earthquakes here, but pretty small adjustments here. We would expect a southeast flank of Maunaloa to adjust as the southwest rift of Kilauea adjusts as well in between there, but not at very high rates is what we're seeing from Maunaloa. So we'll look at the Maunaloa signals here. The tilt meter is not showing a whole lot of change. The scale is really small here. Earthquakes over the last week, there's only 5 dots showing up, so not a whole lot going on there. They're kind of scattered, shallow and deep. The tilt for the last month is showing some more interesting wiggles where it seems to swing down and up and down and up. So it's curious whether there is some kind of cycle happening here that's longer term, that might be external to the volcano, or whether it's some little adjustments within the volcano itself, whether that be to magma filling within Maunaloa, or adjustment of Maunaloa with regard to Kilauea. As the flank moves, it makes more space inside. So for the last month, slightly more interesting, depth versus time. You see there are these deeper earthquakes down at the root of Maunaloa coming in, but nothing alarming, and it's all just background adjustment, really. So earthquake rates are quite low. Some of these days have no earthquakes at all across that area. So earthquakes per week, even those were under, looks like we're under 10 earthquakes here, just 5 earthquakes in the last week. So very, very slow compared to the whole, was that 3.5 year buildup to the 2022 eruption, and even slow compared to the aftermath and recharge that's been going on ever since. So there's the map, very sparse for Maunaloa, and a little bit more full, so you actually can see some pattern of what's happening. But just so you can see it more closely, there's that map of Maunaloa, showing where these earthquakes were over the last week. Just those 5 events. So one cool thing on Maunaloa this last week, the USGS has installed a new webcam. Here it is. This is the last 24 hours. It's down near South Point, looking up at the southwest rift. Looks like it's around a pasture, so you can see the cows walking around here. Oh, one just flashed there. And then southwest rift of Maunaloa would be up in the area up in here. So I'm going to scroll it up. This is their news release. New webcam provides views of the southwest rift of Maunaloa. They announced this was installed this past Tuesday, March 12th. And the camera is named the MSP cam, and it's from Kīlauea, South Point area. Right? It's a pan tilt zoom, so the view might change depending on activity. They can point it where they need to and zoom in and out. So that's the daytime view of it. And we just saw the loop at the Maunaloa summit all the way up here. And you can see that rift zone coming all the way down, and then it kind of swings off the left of the camera like that. Here it is, what it looks like. It's inside this little enclosure that they can move it around with motors. They're installing it with solar panels, radio transmitters, all to allow it to be remotely controlled and operated and transmit all that data back to the USGS servers. There it is, making sure they cut the grass so that it doesn't grow too tall and start blocking the solar panels and the radio transmitters. So that's the exciting news from Maunaloa this week. And with that, we'll just turn to our last volcano content for this week before our video, and that is this week's Volcano Watch article. So Volcano Watch this week is establishing a nascent monitoring program on Pico Basile volcano, Equatorial Guinea. There it is on the screen. Oh, I think it might be an accent maybe missing there, but I'm not sure. That is just offshore of Cameroon. So if you imagine Africa, it has that little nook, and it's right in the nook, that western nook of Africa is where this volcano happens to sit. There's what it looks like. And it turned out that in 2012, so 12 years ago now, they noticed steam rising from beneath the cracked concrete of a telecommunication tower on this volcano. The steaming lasted several days, extended to 2 nearby summit craters, and they realized that they had better keep track of this volcano, and they were not doing so to this point in time. And it's one thing to have researchers come from outside and study a volcano and then leave and have their data. It's a different thing to empower the people who live in a place with the tools and knowledge to monitor their own volcano. And that's really the approach taken here. And this is highlighting a couple of programs that the USGS is involved in. One of them is the Fulbright Specialist Program right here, which paired Dr. Christine Sealing from the USGS HVO Gas Group with all the staff from the University of National University of Equatorial Guinea, UNGE, as well as with the USGS Volcano Disaster Assistance Program, USAID, or the VDAP. Like, these are the guys who, if there's an eruption happening anywhere in the world that the people are not prepared, they deploy, take their seismometers and tiltmeters and everything, and they set them up on the spot, monitor what's happening, and then often train the people who are of the area to use equipment, and they often leave much of that equipment behind as the beginnings of the monitoring network. So those guys are awesome. Great to see them involved and USGS involved and helping them install this station here in 2023 here. Right, so it took about a decade, but now they are on their way to monitoring their own volcano. And while there's been no volcanic activity, the new system has already served as an important source of information by reassuring officials that recent remote wildfires were not caused by volcanic activity. Right? You can imagine that people were concerned after seeing steam coming out of the ground. Could this start a fire? What's going on? And so now they can monitor and say that there was nothing volcanically happening. So pretty cool. You can check this out, posted online in various places, Hawaii Tracker. And we'll leave it at that here for Volcano Watch this week. And with that, Dane, we can just mention Community Corner, for which there is one more event in March in the national park coming up here on the 26th, this coming Tuesday. That's Emma Ka'ili Kapualono Nakuina, Extraordinary Woman of Hawaii. So this is going to be Park Librarian Martha Janet Hilverson at the After Dark in the Park talking about this amazing Hawaiian woman. So that will be streaming online for you guys on Tuesday. And if you're around, come in person. One other thing that we mentioned before, construction still ongoing in the national park, right? Those similar areas still ongoing, similar closures happening there. Although we also mentioned tree molds, and they're also announcing restrooms at Uekahuna from April 8th will be closed as well. They will have portable restrooms instead. That's ongoing. We did mention before as well that the national park had sought input on congestion in the summit area with a public comment period originally open through tomorrow, March 22nd. However, there has been an announcement that the National Park Service has extended the comment period to March 31st. So a little bit extra time to get your input in if, like me, you haven't quite done it yet. They're really making sure that everyone has a chance to be heard. So take your chance and submit your input there on the National Park website. That is it for our community corner, and maybe some thank yous and discussion and questions, Dane.
Yeah, like to thank everybody for tuning in today, especially in these times when there's not a lot happening up at the summit. You're already, everybody here is kind of our regulars, and we appreciate you guys tremendously. And the likes, the subscriptions, the shares, all that stuff does help the channel to get in more, long-term members is kind of the goal on that front. Yeah, we did. I think we have something prepared, but I think we're going to wait for it for the donations. Give me a nod, Lou, if that's correct. Okay. So yeah, from here we just have one question I have highlighted for you, and I might be the one that takes it because I don't think you've seen this. Dennis asks, I see a crack in Road 130's at mile marker 13 coming out of Pahoa on the new pavement. They have painted marks around it. No worries. I know what you're talking about. It looks just like they had some kind of issue when they laid the pavement. It doesn't look anything resembling the types of cracks that we would be looking for with lava. These are more localized sinking or something like that broke the pavement. They'll need to fix it, and that's what I assume the marks are about.
Yeah, I think the answer, no worries, is right. I mean, the ground does move around that area, even without there being any magma. It's something we talked about before. We can recap that someday as well. There are surveys done in Pahoa, right? That there are all kinds of movement of the south flank even there. And so, yeah, by themselves, cracks are not enough to be of concern.
Right. We did get one more JWS. Do microads correspond to volume changes estimates?
So they can. What they're doing usually is they're using the tilt data and the GPS data both in their models, right? So they'll model certain volumes and geometries combined, because the geometry has a big effect as well. And then say, okay, well, such and such a volume in such an area would produce, especially the satellite signal we see, and the tilt signals and the GPS signals. And so by itself, not so much. But if you have, let's say, a pre-described source, let's say you've had a stable Halima'u magma reservoir for decades, maybe that would have been true before 2018, and you see a signal there, and you've done calculations before, then maybe that one instrument by itself might be enough to give you an estimate of a volume. But when things are changing and adapting in this dynamic, then it's harder to say just the one station. You really would like to have that full satellite view to say, okay, these are all the areas inflating, and it's not just the one area that's always the same spot. So that's a little bit of discussion on that. Yeah, it could be in the right situation, but you'd have to know a lot of stuff already and assume it hasn't changed, which is not where we are right now this decade on Kilauea.
And then we did have a $20 super chat just come through from Scudget Ed, just with a sticker. Appreciate the continued support there, Ed. All right. And of course, we want to thank the Puna Strong and Hawaii Community Foundation through the County of Hawaii through the Hawaii Community Foundation, facilitating the Puna Strong grant, which has helped us immensely get off the ground with the nonprofit, believing in us before we were even a nonprofit. So we appreciate their continued support.
Yeah, and Kilauea Recovery as well. Separate program, just as important to us. Mahalo, you guys. So anything else before we get into our video, Dane?
I don't think so. I think we'll wait and roll the thing we have prepared a little bit later, and we can go ahead and get into the video now. Oh, we did have a $19.99 super chat just come through from Hal. Says mahalo for what you do. Appreciate that.
Wow, guys. All right, so we'll turn to our volcano awareness presentation, and this will be a recap of Dr. Kendra Lin. Let me put the graphic up here on the screen. This was the Will You Be My Lab Partner talk, January 17th, that was given at University of Hawaii in Hilo. A lot of this talk was focused on the collaboration between University of Hawaii, the opportunities for students, and the USGS. That stuff is all super important, but that's a lot of what I cut out because I wanted to give you more of a science recap of this talk and condense it for you guys. So if you're a student or interested in that aspect of it, then go and see the full talk for sure. But otherwise, we will turn to Dr. Kendra Lin and a abridged version of that talk, if we're all good to go here. All right, so I believe we'll leave Carrie on screen here, and Dana and I will come behind this video here. So here we go.
I really, really love studying the mineral olivine. And so it's the most common mineral on planet Earth and actually in our solar system. And if you are ever out for a hike, it doesn't matter where you are on this island, chances are somewhere, some lava flow near you has these little green minerals in it. And those little green minerals are the olivine crystals. And if we have any August birthdays in the room, your birthstone is called peridot, which is the gem quality variety of olivine. So for all you August birthdays, olivine is your jam. First, I think the best example that's laid out is looking back at Kilauea's 2018 eruption. During this time, using the EDXRF, these folks at UHH really put this methodology to the test. They were able to go from a rock to data out of the instrument in about 1 to 2 hours on the fast end, which is really, really cool. And those analyses were conducted within about 24 hours of sample collection, right? So you physically pick up the sample and the clocks kind of starts. You have to drive it back to the lab, you have to put it in the oven, you have to get it ready, you have to crush it. But the analysis itself, really didn't take too much time, which was really informative during those events in 2018. And this was one of the first times in our scientific community that we were documenting how petrology and geochemistry could be used as an active monitoring tool, like really demonstrating how it would be put into practice by volcano observatories or by interested parties during an eruption. Very soon in our scientific journals, we saw one after another examples of other eruptions around the world where other observatories had picked up on this technique, had honed it best for their system, and were starting to publish also these sort of real-time monitoring and insights. So not only did HVO and UHH really set the stage globally, but I think they've sparked a revolution in the sense that this is a new cutting edge tool that's being used around the world, and it's being used so frequently that we're now learning from the other observatories too and refining our approach. And I just find that to be an incredibly exciting time to be a scientist, generally. Which brings us to the recent eruptions and some examples of where this new instrumentation has gotten us and the kinds of things that we're trying to do. So as many of you hopefully know, after an approximately 2-year hiatus, Kīlauea erupted again in December of 2020. Fissures opened up in the walls of Halema'uma'u crater, the collapsed crater from 2018. And that opening phase of activity, these fountains shown here on the top picture, actually were powerful enough to spread tephra, which is just a word we use for airborne pieces of lava and minerals and things. It spread tephra onto the landscape where the old crater rim drive comes around on the south side of the crater. And so with close collaboration with the National Park Service and lots of PPE and safety, we were able to come out to this road surface and scoop up this brand new material. And I bet you can guess what my first question was. Is it the same or is it different? And also, yes, is there olivine? That was absolutely a question. And so one of the first things we did was to process this sample. Of course, we did the EDXRF, and we're going to come back to that. But now I'd like to showcase some of the ways that we can use our scanning electron microscope. So this is called a BSE image, backscattered electrons. Essentially, it's a grayscale picture of a piece of rock. The gray tells you a little bit about the composition. So all you have to remember about these pictures is that bright stuff is rich in iron, okay? And you can make some really basic chemical inferences just by looking at these pictures. So one of our first tasks using this 2020 eruption tephra was to figure out what it was made of. So this first example that I showed you, this is actually a sort of gross, recycled, altered piece of wall rock, right? So when the 2018 summit collapses were occurring, a lot of that rock was pulverized into fine pieces in the collapse pit. And we know that Kilauea's summit is also quite warm, that there's a hydrothermal system there. And the hydrothermal system tends to alter those lavas, right? It cooks them, it changes their chemistry, and you get a lot of secondary minerals that come in and sort of replace the original lava. And that's kind of what this is. It's a bit of a mess of things. A lot of it contains sulfur, a lot of it contains gypsum, and those are two minerals that can be found, you know, in the geothermal areas at Kilauea. So nothing surprising mineralogically, but it was interesting that these altered pieces of the crater wall were covered, you can see here, little bits of fresh magma, right? So the fountains ripped up parts of the crater and threw it out, which was unexpected, for me anyway. Some of the stuff that we cared a little bit more about, because we want to know more about the magma, these are two examples, two BSC images of what we call juvenile material. Basically, that's the fresh stuff. The fresh magma that came up was erupted, the fresh lavas that were quenched. And you can see, just comparing the top picture and the bottom picture, they look pretty different, right? There are two different textures here. The top one is mostly glassy, sort of a uniform gray color. The bottom one is chock full of little minerals. And the scale bars on these things, remember, we're in a high-powered electron microscope. So this is 100 microns. So if you've got hair on your head, one single strand of hair, roughly, is about 100 microns. Okay, so we're looking at really, really small stuff here. These are tiny, tiny little minerals. And they're, you know, something like less than 1/10 of a millimeter, or if you think in inches, something quite, quite small in inches. And this was really important because it looked like there were maybe two different magmas at play in the 2020 eruption. And we could tell that just based on these pictures. The eruption also spit out what we think are gabbro clots. Gabbro is just a rock name. It's basically mush, right? Lots of crystals mushing around, very little liquid. And you can see here these really big, bright, iron-rich minerals compared to these darker grays. So there's probably 3 or 4 different minerals that make up this clot. And we believe that these things, these mushy mineralic things, probably come from older pockets of stored magma that have had a little bit more time to evolve and crystallize. So this eruption also brought up some older stuff, which was interesting. And yes, there were olivine, thankfully. These BSC images, you know, I've shown you a variety of different textures and different types of materials, but for me, they really are informative when looking at the olivine crystals. So when you go out and you find a lava and it's got those green, bright green specks in it, if you could put those specks into a scanning electron microscope, you might find that they are chemically zoned. So this guy in the upper left, just gray. He's chilling, he's one composition, right? Same color gray across the whole crystal. But if you look at these 3 other examples I've given you, this one has a dark interior and a light rim, this one has a light interior and a dark rim, this one's got light, dark, light. So just by using the BSC images, we can already say, wow, there's a huge diversity in the compositions of these crystals that came out in one eruption. And that's telling us something about how many magmas might have been at play here before the eruption started. Crystals that live together tend to look the same, right? So the fact that there's such diversity here suggests that they all came from different places in the volcano. They ended up in the same place and were erupted together, but they came from different parts. So leveraging this information is one of the ways moving forward that we hope to develop other UHH-HVO co-op strategies for some quick information during eruption monitoring. And we certainly did use this information at the time in 2020. And then, of course, as you know, Kilauea has kept us very busy in the last several years. So one more example from the September 2021 eruption. This eruption did last many months into 2022. But this is an example of very frothy pumice that was erupted at the start of that eruption, right? And so if you remember a few slides ago, I showed you the crater rim drive covered in these tiny little bits of tephra. This is very different. I mean, the scale here is something like, so that's in centimeters, like 11 centimeters. You're talking like at least 6 inches, right, or more, for a lot of these pieces of lava that were thrown up and out of the crater. And so this second eruption at Kilauea instantaneously told us that things were a little bit different, right? And when we look using the SEM images, we can see that, you know, things are, some things are similar and some things are different. So we have our, you know, homogeneous one gray color crystal here, and then, you know, these guys that are zoned. But the kicker was for the September 21 eruption, we only saw fresh magma, right? There was none of the altered wall rock, none of the gabbros that we've found so far, you know, none of those other things that made the 2020 eruption so messy. And so already, between the space of 2 events following the 2018 summit collapse, we've seen major changes at Kilauea. And very briefly, to show you that indeed these things are different, you can actually measure those olivines, and you know, the dark versus the light colors in the grayscale images do translate to chemistries. So on these figures, I've basically just shown you for 2020 on the left and 2021 on the right, the olivine forsterite. Forsterite is just a fancy word that means the amount of magnesium relative to the amount of iron in the sample. And so the 2020 and the 2021 olivines, these 2 figures look pretty similar, right? You've got a big gray peak at forsterite 82, another big gray peak at forsterite 82, and then this dark peak at 88, and again, a dark peak at 88, right? So a lot of the chemistry of the solid materials of these minerals is actually the same from one eruption to the next. So using all of this information, we can actually piece together where magma's moved inside the volcano. And sometimes the pathways are the same. They pick up the same type of solid materials. And there's a whole lot more that goes into that, but for the purposes of today, these are just sort of highlights of the different ways that we're trying to use mineral information moving forward, in addition to the EDXRF analyses. And of course, as you know, 2023 was very busy. We had 3 eruptions at Kilauea, and the short presentation on that is that it's a work in progress. I can't express enough how we can't keep up. Like I said, it's group effort and it's a tremendous amount of work. We cannot keep up sometimes. But we do have the EDXRF results, which I will show you here. So we had looked at an early version of this plot, right, when I explained the use of MGO and variations over time. The blue diamonds here, that's Pu'uo'o. The white circles, that's the Halima'uma'u 2008 to 2018 lava lake. And then the 2018 eruption on the Lower East Rift Zone is this big range in the gray diamonds, yeah? And these are all of the new eruptions. So in yellow is December 2020, in orange is September 21, red is January 2023, and green is June 2023. And September is still pending. These are the WDXRF data, so that we could look at a bigger time span. And we don't have those data back yet for the eruption that occurred in September. Underscoring the importance of having EDXRF, because it's been how many months and we still don't have those data back from the mainland lab, right? But the nice thing is, if I were to hedge my bets about what the September composition looks like, it's probably something very similar, right, to 2020, 21, 23. You know, all these things are showing sort of the same information. They're a little bit warmer, a little bit hotter, right, than the old lava lake in Halima'uma'u, and they're a little bit higher, you know, than the end of the Pu'uo'o eruption, but lower than 2018 Lower East Rift Zone. If we take another look at the potassium, right, another one of our minor trace elements looking for changes in melting of the rocks down in the mantle, you can see that our recent eruptions have potassium kind of at, you know, this level, very similar to 2018 Lower East Rift Zone. both of which are higher than previous summit eruptions. So while this is a study that's ongoing and involves many different types of data, for which I am not the expert, what I can say is from these data sets, it looks like something changed at Kilauea in 2018, right? And that we are seeing that same flavor at the summit today. And that's something that's kind of interesting, and we hope through many additional studies of our academic partners and others interested in this topic that we will have a better understanding of what that change is and why. It's only been, 5 or so years since the events of 2018, and these things often take an entire student's graduate time to unravel. So we're eagerly awaiting more information about what this means. In some of my remaining time, I'm just going to briefly contrast those examples with the Maunaloa 22 eruption. So after over 38 years of repose, Maunaloa sprang back to life in November of 2022. The eruption began in the summit, Mokuaweoweo, and was only active there overnight for about 6 hours. By the early morning hours on the 28th, the eruption had migrated into the upper northeast drift zone. And this was an exciting time scientifically because it was our first chance to better understand Mauna Loa's plumbing system in almost 40 years. And so all hands on deck in the lab for this quite unprecedented eruption in our lifetimes. And everybody came in and supported that lab effort. And I hope when you look at this plot, you agree with me that it doesn't look like Kilauea 2018, right? Here's our magnesium and our calcium, our temperature indicators, and they are flat. No changes, right? So this is time on the x-axis, the approximately 2 weeks of the eruption. We had a great time series of samples running those EDXRF analyses, and everything was exactly the same. And in fact, on this plot are also the early summit samples in the summit crater and things down on the northeast drift zone. So you've got 19 kilometers of eruptive fissures and 2 weeks of an eruption, and they're all the same. Which is totally different from what they saw for the Kilauea lower east drift zone eruption in 2018. And it was a little surprising. That wasn't maybe what we expected. And it turns out there are some serious questions raised by these rather boring results otherwise. How do you erupt that much magma that's all the same composition? Where do you store it? How much is that? What is the size of Mauna Loa's reservoir? These are all exciting questions that come out of a data set that is otherwise unremarkable. What was nice at the time was that our UHH partners got to showcase a longer-term data set for Mauna Loa that was put together by a UHH Geology Department alum, Will Wooten. So he had done quite a lot of work with the UHH faculty to look at EDXRF analyses of Mauna Loa eruptions from 1823 to present. And so they already had this great database, and they plopped those 2022 samples onto these figures, and they could instantly say, is it the same or is it different? So not only is 2022 really homogeneous, but it's also the same, basically, as the 1984 eruption. So these were pieces of information that we were able to get probably within 48 hours of the start of the eruption. We were starting to make these comparisons to say, like, whoa, Mauna Loa has come back to life, and it's actually the same as it was in 1984. What does that mean, right? So in real time, these things are super helpful. And the one other thing that I'll say about sort of our real-time efforts, right? We place this emphasis on getting certain information quickly to make decisions or make informed interpretations. But there is something to be said for the balance of that quick near real-time chemistry and longer-term research. So during this eruption, during that 2 weeks, myself, my colleagues in the lab, it was very, very sad. We couldn't find any olivine crystals. I was devastated. And we, at the time, we really thought that these things might be apheric. So apheric meaning no minerals. This is one of those backscatter images with the tiny, tiny crystals. We saw a lot of those little crystals, but nothing like an olivine crystal that you could see with the naked eye. And so we said, oh, there's no minerals in here. That's a bummer. But I was persistent. And after crushing, sieving, and picking many trash cans worth of volume of tephra, we have found extremely rare olivine crystals. So, we've been through many trash cans volume, and I have 60 olivine crystals that are about the size of a millimeter, right? Needle in a haystack, am I right? But they're super important, right? They're telling us a part of the story that we never would have gotten in near real time because it takes time to process these samples. And this is the power of the collaborative teamwork in all of us rotating through the crushing, sieving, picking, and our amazing undergraduate students that have helped us with this. So this is kind of a new in the last year discovery with this eruption. We're learning a lot about these crystals and what they can tell us about Maunaloa. And it really, for me, as a young scientist, emphasizes the balance, the importance of balance, right, between the near real-time approach and the longer-term research approach. Both are needed to fully understand these systems. Finally, I will leave you with this notion that we are constantly learning. So one of the things that I am trying to do now is to use these olivine BSC images in near real time. It's a totally different talk, so I won't, get into the details, but basically these little olivine crystals are stopwatches. They record time and can tell you how long magmas have sat around before they erupt. And if you know a little bit of math and a little bit of computer coding, and you can interrogate these grayscale images, you can actually get time, which is very, very cool. And normally to do that is a lengthy process that involves multiple instruments and lots of time, and it's not a very quick thing. But with one of the undergraduate students that's working with us, she's testing a method where you can do this in a couple of hours. Same type of near real-time approach, and her results are very promising. For this particular example, my long, arduous method gave a timescale of 60 days, and her very fast grayscale method gave the same result. Through a number of observations of natural samples and natural processes at well-studied volcanoes like this one, in combination with experiments, so well-controlled experiments in laboratories across the world, we know how fast the atoms are jumping in the atomic lattice of the mineral. And that's temperature dependent, right? So when it's really, really hot, those atoms move a lot faster. And when it's cooler, they move slower. So if you know something about the composition, either from grayscale or an analysis, something about the temperature, hey, we've got our MgO and our calcium, right? You can piece these things together and use diffusion equations, foundational mathematic equations, to actually run a simulation to recreate what you've measured. You find a best fit to that, and it gives you a timescale. And certainly there are uncertainties on these numbers. It's not just 60 days, it's 60 plus minus some amount. And that's one of the things that I get very excited about. I said I really love olivine, and I love to study it. And this is another cutting edge tool in our field, especially in volcano science, globally. And so bringing it here to HVO, putting it to work, and really testing it really rigorously to see if it works here is exciting. And I hope the students are excited too, because we can now do all of this in-house here at UHH. It's wonderful.
All right, thank you, everyone.
Thanks very much.
All right, you guys. So that was Dr. Kendra Lynn with her presentation. Dane and Lou were on the scene when that occurred there. What do you think, Dane? Seeing that one again.
Yeah, good recap. Go back through it. It's always nice to see somebody, really enjoying their job, essentially, and I feel like she does. Enjoy what she does at the USGS. So yeah, it was great to. And it was actually a really good talk because I thought it was going to be pretty dry going into there, but there was all kinds of interesting tidbits that she was able to drop in and help us figure out how it relates to everything.
Yeah, for sure. Yeah, and just to recap, I did leave out all the thanks and emphasis you put on the importance of collaboration with University of Hawaii Hilo and other researchers across the country too. So. Yeah, I've heard many of the USGS scientists say that they are in their dream jobs, and she appears to be one of those. Yeah. So that's great to see this new generation of scientists also passionate to make the most of this opportunity.
Yeah, definitely. Well, yeah, that was great. What what do we have one for next week as well?
Yeah, we'll keep going.
Or-
We
All
have
right.
plenty of these to keep going through. But yeah, before we sign off, do you guys want to mention our donation drive?
Yeah, let's go ahead and do that. Do we want to get Lou on here?
Yeah, go ahead. You want me to pop
And
out here? I can pop out.
yeah, we can figure out how to do that. Let's add Lou, and that'll
Hey,
work.
there I am.
All
How's it
right.
going?
I'm
Aloha,
doing good.
everybody.
Yep. Hello, Lou, and thanks for coming out. And what can you tell us about the donation drive? I know you've been putting in a lot of work on this.
Yeah, we've been doing great. I'm going to load up this video here in a second. We've been doing great. We've been getting donations through hvery.org/donate. That is our main source to pick up our donations. There it is right there. Thank you to everybody that's been going there. We've been collecting donations here through our super chats. I saw 2 more, Hal and Ed, both with $20 super chats. Thank you guys so much. As well as on the monitoring 24/7 that I'm running. That is all fundraisers. So that is all 100% going into the HVERY organization. And YouTube hooks us up with that to be able to do a fundraiser through our channel. So that's kind of nice. We pulled another 290 over there. So with the grand total for tonight, as we stand, we're sitting at $1,342. So thank you very much, everybody. Dan and I have been talking a lot for the last couple of weeks and brought it up a lot in the last couple of days about how we want to start letting you guys know about a lot more that goes on with the HVERY organization other than tonight, the Thursday night broadcast. And there has been a lot happening behind the scenes and the growth of the organization and what the nonprofit has to offer the community. So I hope we can put that together coming up in the next couple of weeks and present something to you to get you more educated and understand, how important this is for us and for the community of the island. So I'm going to drop that video up there. If you want to say anything,
Yeah.
go for it.
No, go ahead. Let's get the video going. Say thank yous to everybody that's donated in our drive so far. Just give us a second to get it all queued up and we will get it rolling. But yeah, it looks like we've got it.
There we go. Yes, and as we know, it is not 1302 any longer. We are at 1344.
I almost want to see you try and read all those names that quickly, just to see how far you get.
You know I could.
All right, Lou. Well, thanks for hopping on here. And
Yep.
yeah, if you guys want to support us, best way to do so is on the website hvery.org/donate, and we have a donor box set up there. Those are tax deductible donations, and not only that, we get 100% of the revenue, whereas super chats right now we're only getting 70%. There's a whole thing behind that, but yeah, your donations get the best bang for the buck coming to the website and making the donation there.
I do have one more thing to throw in. If you haven't heard already, we're trying to get everybody into the HVERY newsletter so that you can get updates of what's going on in the future. So if you haven't signed up for the newsletter, we're going to drop the link in here so that you can get on board with us there. So I want to make sure that we put that out there. All right. Thanks, everybody. Appreciate it. Hey,
all right, thank you,
you,
Lou.
Carrie and Dano as well.
That's right. Welcome back,
All
Phil.
right. Mahalo, Lou. And yes, we also appreciate Carrie and Dano. Mahalo, you guys, for your heroic effort every week here with our speed of pace and vocabulary and Hawaiian words that are very challenging to ASL interpret. Mahalo, you guys. We appreciate you.
Yeah, so I think that's it for me. Unless you got something else.
No, I think that's good. Yeah, we appreciate everybody joining
Right.
us today. Appreciate the USGS for sharing those great talks and all that data online as well. All our other partners that we'll continually highlight over the next few weeks here. So, yeah, unless there's anything else, Dane.
That's it.
There.
I think we're good.
So, from HVRE, I'm geologist Philip Ong. And where are you? You're over there now. Mr. Dane
We
Blunt.
changed up.
Until next week, you guys, unless something else happens, next week, Thursday, regular time, 5 p.m. Hawaiian time. We'll see you then. Hui ho. Aloha, everybody.